In this video, we're going to be doing our last kind of factoring technique for polynomials. And in this case, we're going to be turning polynomials into quadratics. It might be helpful to review some of the videos about solving or factoring quadratics so that this video makes a little bit more sense. But basically, if we can turn any equation into a quadratic, meaning that the equation has a power of 2, that's its highest power, then we can use any of our quadratic factoring methods or solving methods in order to solve it. So let's see what that looks like. If I have an example like this, here our power is 4, so that's far greater than 2, so this is considered a polynomial. If I can make this a power of 2, then I've created a quadratic, and we could use our factoring technique to solve this. So what I like to do is I like to use another variable. It's called Z. You can pick any letter you want. I like to use Z. I like to call it the magic Z here. If I make this variable equal x squared, then I can substitute Z into my equation and create a quadratic. Here's how that works. Let's say I want Z here to be instead of x, but we still got to keep our power. It still has to be a power of 4. Well, if Z is x squared, well, if I square that, don't I get x to the 4th? So if I square Z, then that's the same as x to the 4th. So I've substituted x to the 4th for z squared, and now I have a quadratic. All I have is a power of 2. So now I can use my difference of squares factoring pattern for quadratics. That's just square root of the first term, square root of the last term, with a minus and a plus in between them both. If I FOIL this back out, I should get z squared minus 16. And so I've factored. But if I replace z at this point now, for what it stands for, it's x squared, so everywhere you see a z now, let's put an x squared in there. Then I now have my correct factored form of x to the 4th minus 16. And now maybe you're thinking, well, why was that necessary? It's not necessary at all. I think it just helps you visualize that this is in fact a square. It's x squared squared. So when I factor it, when I take the square root of it, I get x squared. Sometimes just looking at it as a quadratic helps us factor. So it's not totally necessary. It's just a trick you can use if you want. Use that magic Z there. So if I had to solve this, I would then set each of these equal to 0 and solve. All right. Oops, this isn't our final factored form. What can we do with this? So oftentimes when we're factoring polynomials, you got to check. We could actually refactor this. This is another doubled, or another difference of squares right here. So x minus 2 times x plus 2 would be that first set of parentheses factored. And I still have my x squared plus 4 because we don't have a factoring pattern for a sum of squares. We only have it for a difference of squares. So there's my final factored form. Again, set each of those parentheses equal to 0 and solve. We'll get to that in the next video though. We're almost ready to solve. It's our last factoring technique before we solve. So let's try another one. Let's do 81x to the 4th minus 25. Again, if we say z is x squared, we can replace that, rewrite this as a quadratic. Oops. I said to use z and then I didn't. There we go. So if I square z, I get x to the 4th, right? So now we're looking at a quadratic instead of this higher power here. And we can use our factoring form for quadratics. We're only allowed to use our quadratic factoring forms if it's a quadratic. So we can't necessarily factor this. I'm going to make sure it's a quadratic first. So 9z is the square root of 81z squared. So that goes first. And the square root of 25, or the root, is 5. One gets a minus, one gets a plus. And then if I replace my z there, I get 9z squared minus 5. Sorry, 9x squared. Wow. 9x squared, that's what z is. And 9x squared plus 5. So take a look. Can we refactor any of these? No. So if we set each of these parentheses equal to 0, we could solve for x, and we would solve for this polynomial. So again, it's not necessary to use z. I like it because it helps me visualize. Let's try one more here. Let's do... Alright, so it looks similar to a quadratic so far, but our power is 4. So if I replace z, instead of everywhere there's an x squared, well, this one's the easiest, 7z instead of x squared, right? But this is a z squared, because we need x squared squared. So there's that. So now we have a quadratic. And we can use our techniques for solving or factoring quadratics. This is kind of a, well, it is an x factor technique. You can use the x or you don't have to. Say to yourself, factors of 10 that add up to 7, factors of the last term, or factors of multiples of the first and last. Remember it's a times c. Well, 10 times 1 is just 10. And 7 up top, they're both positive. So factors of 10 that add up to 7, pretty easy. 5 and 2, those add up to 7 and multiply to get 10. So those are the factors that go in my parentheses. There's a 5, there's a 2, doesn't matter which is in which. And we had z for a letter. They're both positive. If we FOIL this, we'll get back to the beginning. So our last step is just to replace z with x squared. You could solve for z. I may show you that in the next video. Just have to make sure and always replace it at some point. You can do it at the beginning or the end. Doesn't matter. So there's our final factored form there. X squared plus 5 and x squared plus 2. So there's another factoring method we could use. As long as we turn it into a quadratic first, then we can use our quadratic factoring patterns or methods. Alright, so good luck turning things into quadratics. Our next video is going to try and cover all of our techniques that we just used for factoring polynomials, and then taking it that one step further to solve. So setting each of our parentheses equal to 0 and solving. So we'll see what happens there in the next video.